Okay, today I have a Apple MacBook Pro. That is A1286, and the logic board number is 820285A. This has a graphic kernel panic error. As soon as you put a level of stress on the GPU, or do a GPU firmware test, or and so on and so forth, the unit tends to give out a grey screen. Some units may give switch off and restart and things like that. This particular one just gives out a grey screen. So I can assure you that it is nothing to do with the VRAM or the GPU itself. Okay, so I'll quickly refer to the schematic and the board view, and basically show you what one is changing and where its location is on the board view. Okay, so this is the section where you need to pay attention to. It's page number 86 on the PDF schematic. The area that I'm more interested in is further down on the right hand side. Okay, this is the area I'm interested in. The capacitor, in short, the capacitor that has actually have a problem, and it is an ongoing issue, is where it says critical here, C9560, which is a 330 microfarad 2.0 volt, and it's a polytantalum capacitor, and it's a common issue, this actually. Now, where this is located on the board view, let's just have a look. Okay, so it's already on there. Okay, I've got to give credit to Paul Daniel for designing this cracking piece of board view software. Thumbs up for him. Thank you very much for doing that. Really appreciate it. Okay, so we're looking for C9560, which is a polytantalum capacitor, and it supplies. I mean, the pin 2 is ground, and pin 1 is PP1 V8R1V55 underscore SO GPU underscore ISENS or ISNS score R, which is, I believe, the regulator. So this is the main problem. This is where we have all the issues, basically, in terms of the graphic. So it is not the graphic chip or the VRAM, it is that tantalum capacitor. Okay, so what's been done to it to try and resolve this issue? Okay, let's switch camera back into the desktop. Okay, so the actual capacitor, quite obviously, is located above this inductor here. Okay, and what I have replaced this is the capacitor what I've replaced it with. This is a solid state capacitor. I did have to remove this a little bit further down, but bearing in mind that there's a very tiny 00, I believe this is 0201 or 0402 capacitor, if I'm not mistaken, basically to try and create that space to fit this tantalum, solid state capacitor. It was an absolute nightmare because the gap for this to be the pads spacing, that's a tantalum. This is what we're up against. And the pads were so close that I wanted to put one of them on. I am not going to put the tantalum because more than likely it'll fail again. But having to put this solid state capacitor, it would be a long-term fix. So it is a 330 microfarad, 2.5 volt, and I believe that you should be okay with that rating. And as I said, I did have to remove this coil pack further down, but bearing in mind that there's a small capacitor here, you do not want to sort of push the coil pack against that. So there's enough space for that, but just enough space to fit this. But this God help us, this was an absolute nightmare to put on, actually, because you can't solder it underneath. I had to heat up the PCB, make sure that the pads, the solder on the pads are liquidous, and then line up the capacitor while the solders were liquidous. Now I do use a special, well, not special, but it's leaded solder, which is, I believe, it's an SN6238. Effectively, what that means is that the even though that you remove the hot air station away, the solder stays liquidous for longer versus sort of like the SN6040, if it makes sense. So it's easier for me to drop that in and line it up, and then by then the temperature sort of goes down, and then it becomes liquidous, and it holds the capacitor in place. But you can't see whether if how much of a space I've left in between the two pads. This is just an estimation of where it should be. So that's that. But saying that, I sort of actually removed this capacitor completely, so I can have a clearance of a view as I'm sort of dropping this, that I'm not shorting the two pads together with the pins under the solid state capacitor. But anyway, that's that. That is the sole reason why you're having the problem. The tantalum capacitor, which was removed initially from the board, is there. I've dropped it down. If you can see it, there it is. And what does this read? So this, I've tested this capacitor here. That reads just under 310 microfarad, which is absolutely fine because you have that plus and minus 10% tolerance. So let's read this capacitor and see what sort of value we get. Remember, this should be a 330 microfarad. And it's hitting 373.3 microfarad. Okay, let me change the probe around. Should get the same reading. Oops. Hang on. I don't think I've probe connected onto the pad. Probing onto the pad properly. Yeah, so 34706. I will turn it around because I flipped the chip the tantalum capacitor before. And both ways, it's sort of, it doesn't matter that, but it's I'm just doing it for the sake of it. 373.6. Okay, and this is 330, so you can have a plus or a minus, but not to an extent where it's showing that high of a reading. Now, funny enough, I tried testing this capacitor with an ES Atlas 70 plus ESR, and the ESR is showing as fine. So it's coming up. There's nothing wrong with this capacitor, but the readings are higher than what it should be. So that's been replaced. Okay, now let me put the unit back together and run a test on it. If everything else is okay. Yep, as far as I can see, everything else is okay. With the Apple boards, there's so many sort of ribbons you've got to sort of keep an eye out for. Sometimes it can be quite annoying. I'm going to have fun putting this together. What is going on here now? Come on, you bloody... Get my tweezer because I need to pull these ribbons out. This keyboard connector. That's got to be out, out, out you come. There is one hidden somewhere here. I'm sure there is one hidden somewhere here. Okay. Okay, and there is one more. Right, okay, fantastic. So that's in place. First thing first is I'm going to sort of put screws for the DC in. Let me grab my screwdriver. Okay. This board has actually come from London. It has been in another workshop, and unfortunately those people have actually, apparently the customer claim, been told that they've replaced the GPU and they've replaced the VRAM, and unfortunately the problem didn't go away. I'm getting myself all confused now. Right, let's put the fan back in. Okay. Wow, it's amazing how hot this particular unit runs, you know. Put the fan connectors back in. Where's my magnet? Give me my magnet. Hopefully the solid state capacitor will last a long time. Some of the solid state capacitors that are on high-end PC motherboards are like up to 50,000 hours of lifetime. That is absolutely amazing. That I'm referring to Japanese solid state capacitors. Okay, so that's done. Let's put the LVDS connector back on, or the cable connector from the cable. Nice and gently, be careful. Okay, now I'm going to put a Kapton tape over this, just for the sake of it, so just bear with me. I would like to put a music on the background. I tend to sort of enjoy working with music being back in the background, but unfortunately the problem we have with YouTube is I'll get a strike. I'll literally get a strike on my video, copyright strike I should say. So for that reason I can't do it. Okay, right, let's move on to the rest of the connectors. Just make sure that they're nice and clipped on properly. Yep, that's on, that's on. They're so tiny connectors, you know, you probably sort of like think to yourself, is it going to come off? Is it going to, you know, just pop out from the thingy? Ah, I made a mistake here. Spotted something. I made a stupid mistake. I've got to take this fan off. There's a little connector that, there's a ribbon there that hooks into this connector. I've not put that in. So let me sort this out. Okay, I would like to sort of put a bit of a I'd like to put a bit more Captain tape on this one as well, because it's a very small okay, that's been done. Now put the fan back on. It's the awkward ribbon, keyboard ribbon, that's always the awkward one to deal with. Okay, so maybe not this time. Okay, fantastic. Let's make sure everything else is on. It's on. Right, okay, I think we're good to go. I'll just double check all the contacts and make connectors and just make sure that those are in place. That's in place. We're okay here and we're okay here. Fans are connected. Okay, now it's got to be the battery. So let's hook up the battery. Okay. And it's a weird screwdriver you've got to use to put the battery screws back in place. It's like a triangular sort of, like a three sort of a star shape, whatever it is you want to call it. Okay. Okay, I'll try this. Radio. Okay, let's moment of truth. Let's power on the unit. I get a fan spin, and I get the chime. So fan spin. You'll have to hand fire now. Yes, it's running a shitty, a crappy old HDD, so the load up time is going to be, boot up time is going to be long, so you're just going to have to hand fire. Move all the stuff that I don't need. You can hear the DAF hard drive ticking away. Absolutely crap. Right, one thing I can't do is show you who the laptop belongs to. In fact, it doesn't matter. I can't see that being an issue. That it doesn't matter. I'll let this load. I'll be back very shortly. Okay, I'm back. Just get rid of all this. Okay, let's get rid of all this. Right, okay. So as I said to you before, as soon as you stress test the GPU, the thing sort of crashes out on you. You get the kernel panic error on the GPU. So let's just run sign bench. The unit does belong to Damien. That's all I can say. Okay, and what we're going to run, and you can probably see this on the screen. I don't want to put the unit. Why is this? The stickiness on this is gone because people have been running REFLOW. I'll put double-sided tape and just put this across, but that's beside the point. There you go. Where is it? Come on, camera. Come on. I do not want to touch that foam. So what we're going to do is run a OpenGL test. And see what happens. Usually it won't even open the application, it literally sort of shuts the screen off with a grey background. So I'm just going to leave that running for a couple of minutes. Right, no need for this multimeter. I mean, I tend to buy Samsung solid state disk drive, the Pro series, which is cracking, you know, SSD drives with backed with 10 years manufacturer guarantee. I can't see anything better than that on the market. So it's Samsung Pro series. Now, funny enough, I've noticed that this program, the program itself tends to crash for some reason. Don't know why it does that, but it does that. Did I block the ventilation? You piece of shit. Come on. I bet it probably did sort of shut the... Because this thing, when it's on test, God help us, Jesus Christ, it's hot. It's literally fucking hot, the back of the fan. I must have blocked the ventilation and overheated the GPU. So, forgive me, I'm going to have to restart this. Yep, I have actually overheated the device. Because I think the foam have actually stopped it from... Jesus Christ, man. Oh, that's hot, that. Yeah, it's about time that the fan comes into a full speed. Yep, that's more like it. Nice and cool. So I'm not going to turn the laptop back the way it was. I'm just going to leave it like this. Da, 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 da. Come on. Oops. Get it as close as possible. See, as soon as what's happened here is that I blocked the fan, and by blocking the fan, the GPU have actually overheated, and that's why it crashed out on me. Basically, you do have the maximum temperature threshold on any IC, and this time around, unfortunately, what's happened is I've reached the threshold of the GPU. As a result of that, it bloody crash. And I will prove my point. Just wait till sort of this operating system loads. This is not my test drive. This is the customer's own hard drive that came with the device. Yeah, I know it's been shut down. Don't worry about that. That's fine. Absolutely fine. Yep, that's absolutely fine. I'm just going to wait for a couple of minutes for the hard drive to finish loading. a chap who sent this unit in, Damien, from London, as I've said before. Okay, and I shall run the test now. Yes, it will get hot, but it's not going to fail the test. Let me switch off the lights so you can get a better view. I bet you £1,000 that it's going to pass. It crashed out before because of the overheating issue. There we go. So we'll just hang fire until the test is finished. So for you viewers and for your satisfaction, I'm just doing this. Okay, so I've got 15.69 frames per second. That's been done. Now, just for the sake of it, I'm just going to run CPU benchmark on it as well. Leave that running for a couple of minutes. Ooh. Now, in terms of the capacitor, the tantalum capacitor, I wouldn't recommend using this same type of capacitor. It was very tricky to try and put that solid state capacitor, especially with the gap issue. And let me see if I can grab one out of my salvage. Let me see if I can show you. So this is something what I put in. This is not a good quality. The one I put in is a good, much better quality capacitor. So as you can see, let me do a quick comparison. Look at the size difference between the two. Let me just see if I can show it to you guys. Just look at the size difference on them. Come on, focus, you stupid thing. Yep, there we go. So see the size difference. Furthermore, the contact space. So technically I've had to fit make contact of these two pins on the PCB where this was initially fitted, and I think I've been lucky enough to do that. Well, technically I've had a stead. Anyway, enough of my personal credit. Okay, so yeah, 220 CP, I don't know what the crap that stands for, but in terms of the test, I'll probably rerun the test again for the OpenGL one more time before sort of putting a conclusion to this video. It's amazing how hot these MacBook Pro gets, you know, absolutely amazing. There's no ventilation. God knows where it sucks the air from, because there's no ventilation on the front of the unit. I mean, when I say front, underneath the unit, for the air to be sort of brought in and then back out through the back via the fan. So I just don't understand why Apple would not do that. It just doesn't make sense. .85 frames per second. Okay, so that's it. That's it really. There's no GPU issue. There's no VRAM issue. The actual problem lies on the tantalum capacitor. So again, going back into the board view. Okay, just recapping what I've done. Let me get the schematic up. So we're paying attention to the this area, and we're replacing the C9560, which is a 330 microfarad, 2.0 volt, plus or minus 20% tolerance, and it's a polytantalum capacitor. And I have replaced it with a solid state capacitor. Again, as I said to you many times, it was quite tricky to put that on. Versus a capacitor that you can actually see where the soldering points are. With that, it was very tricky, but it's been done now, and hopefully that'll last a hell of a long time versus the tantalum capacitor. So I think this is it really. I hope you sort of fix your own units, and if it's been helpful, then it's been helpful, but thank you very much for watching.